Good morning, everyone. Welcome to DEV309. My name is Gunnar Grosch. I'm a developer advocate at AWS. Excited to see so many of you already Monday morning.
Hello, everyone. I'm Sridhar Pandey. I'm a principal product manager, and I lead developer experience for Serverless. Happy Monday morning and happy reinventing.
All right, so this is a code talk where we are going to look at how we can make use of AI coding assistants, specifically when we're working with serverless applications. And kind of what we're expecting is that perhaps you haven't used AI assistants that much for that use, but maybe many of you at least know things about serverless. Maybe, we'll see. So in this next hour, we're going to walk through how we can use these types of tools to build serverless applications. And we're going to build both front-end, back-end with the help of an AI assistant. And then, since this is a code talk, it is interactive. So if you have questions, we'll try to answer those as well. But we do have some things we want to make sure to get through, so we'll try to power through as well.
All right. Before we dive into the details and the session, let's level set on what developer experience means for serverless. You can think of it as two distinct but interconnected loops, the inner loop and the outer loop. The inner loop is where you'd likely spend most of your time on your local development environment. It's all about rapid iterations, write code, test locally, debug, and repeat. The goal here is fast feedback cycles. On the other hand, the outer loop begins when you push code from your device to production or staging or integration testing environment. It includes CI/CD pipelines, staging, deployment, testing, production monitoring, and so on. The cycles are less frequent, but much more high stakes. The outer loop involves team collaboration and coordination, and this is where works on my machine meets reality.
All right, so the AI assistant we're going to use for this is Kiro CLI, the artist formerly known as Amazon Q Developer CLI, rebranded a couple of weeks ago. So Kiro CLI is a CLI, a tool that we can use within our terminal and that then have access to large language models. It has access to adding capabilities through MCP servers. It allows you to do a lot of the things many of us as developers do through the CLI, but with the help of an AI assistant. So that is the tool we'll be using. And we will be using it within an IDE. But you can also run it just in any terminal window as you want as well. So with that, I think we've set the baseline pretty much. So let's look at what we're going to build in this session.
All right, so we'll build a simple image generator application. At the core of this application, the backend is an API that calls a Lambda function, which is written in Node.js. The Lambda function then calls a Bedrock model to generate the image. In this case, we will use the Titan Image Generator v2 model, and we will use S3 for persistence. We'll also add a front end to this app, which will be built on React with Vite and deployed with Amplify hosting. And lastly, we'll set up observability for this application with CloudWatch application signals, X-ray, and use Power Tools for structured logging and to gather additional insights. And we'll also use CloudWatch Lifetail for real-time debugging if the need arises.
I think we'll skip over to the
demo,
right? All right, so time to get building. And I'll be doing the building from down here. What we see right now on screen is the Kiro IDE. Kiro is an IDE that has AI capabilities. But like I said, we're going to use the Kiro CLI. This is just my preferred IDE. You could use Visual Studio Code. You could use whatever IDE you want with the Kiro CLI. So the first thing I want to show is kind of what we can do with the help of Kiro CLI. What we have so far in our project is basically just empty folders, But what I have done, just to save some time, is to create our front end, just a clean install of Vite with React. So it kind of just looks like this for now. We all know that installing everything through npm takes a while, so just saving us some time. All right, so right now we have my terminal. We can open up Kiro CLI. That is then going to load. And let's see what we have here. So what you can see straight away is that I have a number of MCP servers that I've added to my configuration. All of these are now in the disabled state. The CLI, or the MCP servers that we have, I'm using a bunch of different ones from AWS. You can obviously add any type of MCP server that helps with your workflow. I want to show just kind of how this differs when we start adding these MCP servers, so you can see kind of how that enables you to be more powerful, I'd say, with the help of these tools. So what I want to do just to begin with is to tell my Kiro to just create a serverless application now. I'm going to copy-paste prompts, so you don't have to see me writing everything. But right now, I've opened it. I can start chatting with Kiro. And it's using different models behind the scenes. As you can see here, with Kiro, you have access to Claude Sonnet 4.5, Claude Sonnet 4, Claude Haiku 4.5. And you can choose which model you want to use. And as always with these large language models, they're good at different things. So depending on what you're doing, you can either pick a specific one or stay in that auto mode. I'm going to stay in auto for now, meaning that it will select itself which model to use. But now I can then start asking it, just like any LLM. But with what Kiro CLI is able to do is that it has access to my file system, so it can actually start doing things for me. So the first thing I want to do now, with MCP servers disabled, I want to tell it to create a new SAM project. SAM, a serverless application model, the way we can, with infrastructure as code, easily build serverless applications. I want to have Node.js 22, an HTTP API, and 2 Lambda functions. So this is basically the architecture that we looked at before. Let me just create it in the backend folder. So what's going to happen now is that Kiro is going to use the knowledge it has in that large language model, and it's then going to start doing things. And it now suggests that it's going to run this. It's going to do a bunch of commands, create a file or a folder. It's going to go into that folder. It's going to run SAM init, meaning that it's using the SAM CLI to create this application. But basically, it's running a bunch of CLI commands for me. So I can press yes and allow it to do this. So that's cool. It means that based on that model, it has a lot of knowledge that it can use, basically from the documentation probably that it's trained on. But what these MCP servers allows us to do is add additional capabilities through different types of tools. And the first one that we want to make use of, so I'm not going to run this command now, because I don't want it to actually do this. So I'm going to cancel. There we go. And then I'm going to enable my MCP servers instead. So first one is AWS Serverless. Maybe you can explain a bit what that one is.
Yeah, so the AWS Serverless MCP server, which we launched earlier in the year, it's an open source MCP server, and the idea was to combine the power of AI assisted coding with the serverless expertise to help you throughout the entire life cycle of your serverless application development journey. So talk about best practices, deployment, as Gunnar will just show us how it picks the right tools and guides us through the right deployment model and so on. And it goes all the way through to operations such as monitoring, looking at metrics and suggesting what could be going wrong with the application or what could be improved and so on. Then we went a step further, and last month we added specialized MCP, ESM, event source mapping tools to the MCP server to guide you through selecting the right configuration for your event sources and troubleshooting if something were to go wrong.
So these additional tools means that instead of just relying on the models knowledge that it's been trained on, it can actually do very specific things. So now I've enabled those. I also enabled one specific for AWS documentation, meaning that it has knowledge from all of the AWS documentation. There's also one with AWS Knowledge MCP server, contains additional information and tools that it can use. I also have one for frontend that we'll make use of later. All of these, the information and how to find them will be shared in the resources at the end as well, so you'll be able to get that there. So what we can do now is we can check /mcp, let's see. Oh, now it, there we go. Let me restart it, Kiro CLI. So now it has access to those MCP, and we're gonna basically try again and see what it says. So list the available serverless tools. So let's see what it says. So now we can see that, well, these are the type of tools that it can do. So for instance, we saw before that it wanted to run SAM init as a command. Well, now it can see that it has access to SAM init as a tool instead to be able to do this, and a bunch of other ones as well. So now with that, well, we can then try to create this project again. So let me paste a prompt. Once again, create a new SAM project, create in the backend folder. I wanted to create that project. Both of the Lambda functions should now return just hard-coded JSON to begin with, since we're not connecting it to Bedrock just yet. I wanted to run SAM build as well, which is another tool to actually build the project. We want to run SAM validate to make sure that everything works as expected. I also tell it to create a change log, and this is something that I use with AI Assistant. So for everything I do, to keep track, I always keep a change log. So everything it does basically ends up in an markdown file for me to be able to review afterwards. So let's try this again and see what happens. So now it says that it will do this. And you can see the difference here. So instead of saying just a long CLI command, it now says that it's going to run the SAM init tool for us. It's going to create an image generator with Node.js 22 and so on. So now I can say that I want to run this. Let's say that we're going to trust it to run. There we go. So now Kiro is going to run the tool for us. 65,000 attendees running Kiro at the same time, so I have to give it a few minutes. OK, so now it's running. Oh, it failed to validate. Let's see. There we go. And what I think is pretty cool with Kiro is if something fails, well, then it looks at that error message and tries to adjust itself. So I don't have to try to find what error it was, what happened. It's instead going to do that itself. So here we go. So now it's generating this. So it generated our initial backend, as we can see, basically a hello world example using SAM init. And now it's going to start adjusting it based on what we needed, our tool endpoints, for instance, and so on. So once again, I'm going to trust it to make these changes. It's now updating the template. And trust it once again. The first few times we're running commands, it's always going to ask you if you want to trust for this session or if you want to just say yes or no every time. All right, so it's creating my initial Lambda handlers with just static JSON to begin with. It's creating a package JSON for what we need. So now, through that simple prompt, with the help of those tools from MCP, it's able to start creating everything I wanted it to do. There we go. You can see that it's still using the serverless MCP server, now with the SAM build command. And now it's doing SAM validate with lint. It's now going to create a change log for me as well. Here we go. So keeping that change log, I think that's usually, for me, a great way to keep track of what's happening within my projects. Since these AI tools, they're able to do a lot of things, so keeping track of exactly what it's doing can be hard through just the CLI. It's also doing some initializing a Git repo for me, and here we go. All right, so now it's done all of that through that simple prompt. Created a new project, created an HTTP API, implemented 2 endpoints with Lambda functions, and it's run SAM build and SAM validate. So now it's basically ready for us to be able to deploy this.
And if you did not want to do even that, the MCP server has access to a well-curated library of patterns through serverless land. So you could have just started with that, hey, get me a serverless land that has an API gateway connected to a Lambda function, and it would have gotten you that as well. So you have options here.
Yep. All right, so now we have that done. We can basically go ahead and deploy this first version of our application, and then fingers crossed, it might work. So I'm going to open a new terminal. I'm not going to tell, I could tell Kiro to actually do the deployment, but I'm going to do it manually in this case. So let's go into the backend, and let's run a SAM deploy and guide it. So this is going to be my first deployment. Oops. Oh, sorry. There we go. Something is outdated. Let's call it image generate. December 1st today, right? US West 2, sounds good. Confirm changes, no. Create roles, disable rollback. We don't have any authentication to begin with, which is fine in this case. Here we go. So now it's going to start deploying this for us. And as soon as this deployment is done, it's going to take a couple of minutes usually through CloudFormation. Then we can basically try it out. And the normal way to do this is, I'm sure most of us would, we look at the output, we get the API endpoint, we test it through Postman or through curl or something. But this is another way where I usually use the AI assistant to help me with this. And you can do it in multiple ways. It can help you find the resources for you. So instead of me having to find the correct API endpoint, I can tell the CLI to do that for me. I can also then tell it to actually test and make sure that the output is correct. So here we go. So it's now deployed, and we can see we have the API endpoint. So yes, I could use curl. I never remember the exact curl commands, honestly. I've been doing the development for 25 years now. I have to Google it every time.
You're not alone.
No. So this helps me so much. All right, so now let's try it out then. So I have my test prompt. Get the API endpoint from the CloudFormation stack. This is why I shouldn't have changed the stack name. All right. Rookie mistake. Image gen API. That's not at all what I called it. What did I call it? Let's see if you can find it without even mentioning it. Here we go. So I'm telling it to get the API endpoint. Now it wants to deploy. It's already deployed. There we go. So now it's going to try to get that. Nope, that's not the correct name. So now it needs to find.
The name had a December 1 in it.
I know. So let's see if it can. So now it's going to list. Let's see if it can find it. This was on purpose.
Yeah.
There we go. That is not correct. Oh. That is not correct. It has a different name. Let's see. What was the name? December 1st? Yep. Okay, I trust Kiro. There we go. Yay. OK, so now it's going to get that for me. Now it has the API endpoint. Now it's going to test it. And as you can see, it's basically using curl. But yeah, it knows the command that I don't. Both endpoints are working. These are the results. So that's very cool. We're able to then start testing the things we deploy straight away just by prompting it again. So at that point, I think we can go on to the next part of the architecture. And what I didn't say before is that what I tend to do when I build these types of applications, specifically with AI assistance, but I kind of do it otherwise as well, is to break down the architecture and do it step by step. So that's what we did now. We created the API and the initial Lambda functions. Then we start adding the next parts of it. And the next part in this case could be the S3 bucket, for instance. So let's do that. Let's do the prompt. Add an S3 bucket to the SAM template, update post generate to create a placeholder object, and then update get images to list the 25 most recent objects and return pre-signed URLs. And that's going to be important in our architecture because we wanted to generate images, and then we want to be able to actually view the images without making this entire bucket public, because that's a big no-no.
Yeah.
Least privilege IAM for S3, rebuild and redeploy. So let's see if it's then able to actually do those commands as well. And update the changelog. So here we go. Add S3 bucket, update Lambda functions. And the thing is that I'm not going to prompt it to use tools or not use tools. That's going to be up to Kiro in this case. So the way those tools are built, they basically have capabilities. And when it's kind of matching something that I tell it to do, it's going to pick to use a tool. Other times, it's just going to use the knowledge that it has in the training data from the large language model. All right, so now it's doing a bunch of stuff. We can see in the code it's creating pre-signed URLs, for instance. It's updating our package. There we go. And now it's going to do the SAM build tool again. It's running it, hopefully. So we can see these are our Lambda functions and the code for it. We haven't written a single line of code, but I think it's so far looking like it's generating exactly what we need. I'm going to allow it to run SAM deploy. So that's a tool we didn't use before since I did it manually, but now it's deciding that it's going to use that tool. I trust it, so from here on out, it's going to be able to do these deployments by itself. All right. So Kiro is hard at work. And the next thing then, well, same thing. We're going to test this out to see that it actually works. Sure, it's running. Oops. What do you think? Is it doing something?
Yeah. It looks like it.
Yes.
Sometimes you gotta let it do its thing and not let your instinct take over and like start.
I know. All right. But hopefully it's deploying. I guess we could check that in CloudFormation, right? See if something is happening. Yeah, update in progress. It's just not showing the output at the moment.
Is the S3 object and stuff already showing there? I can't see very well from here, so.
Oh yeah, let's see. So, oops, resources, the functions. Yeah, it's created a bucket for us
Nice.
now. Yeah, and update complete now. So let's see. Now it's updating the changelog for us as well, so we can see that these are the things it's done. All right, so now that's done, so we can test this out as well. So let me just make sure that I'm not going to trick it with the wrong stack name again. Where's my stack name? There we go. OK, so let's try this out. And then when we've tested that, I'm going to show something else that's super useful when using these tools. So now it's hopefully going to test that as well. To generate an image, so far we're only generating a test text file. And now it's testing the output to get images. And as we can see, it's getting the ID of the file, and it's getting a pre-assigned URL that it's able to fetch. So yeah, that works as well.
Nice.
So we've gotten that far. I want to show something that I try to use quite a lot that's helpful when using these tools. With Kiro, you can create what's called steering files. So I'm doing this now in the Kiro IDE. What's pretty cool is that Kiro IDE and Kiro CLI, they're sharing certain things. For instance, the MCP server configuration is shared between those two. The steering files is the same thing. And steering files is basically a way to control the behavior of these AI tools. So I have a global steering file that I use for Kiro that basically tells it what it should do. If you're an AI assistant, you must follow these rules, just to make it very clear. But then I have kind of my workflow, what it's supposed to do. Always make sure to update README or design documents when it makes changes. Do not create additional markdown files in repository unless you're instructed explicitly to do that. Something that keeps happening with these tools is that it wants to always create markdown files to explain everything. So by adding that little line, I'm able to stop it too. I've also told it that it should use commit when it needs to, and kind of my rules for when I think it should. I also tell it how to do commit messages. Bit about unit tests. I don't want it to have big unit tests. It should be very small pieces of functionality. And then I have some things around code style, for instance, how it should name functionality, how it should do documentation. I want it to follow JS doc, for instance, testing standards, security essentials. This one is good. Never commit secrets. And so on and so on. So this is basically how I can control Kiro. And these are, like I said, these are my global steering. So it uses this all the time. What I can do as well is to create additional steering files. And once again, I'm doing it in the IDE now, but these are just files in the file system. So if I don't use Kiro IDE, it's just files that I store there. So I can create an additional one, either a global one, like we had, or I can create specific ones for this workspace. And they're just stored in the .kiro folder for my workspace in that case.
And what happens if, so which one takes precedence?
So if it has a global steering file and then it has a workspace one, it's going to use the workspace steering. So for instance, if I have a global steering file that says always use Java, and then I have in my specific my workspace steering document that I want to use Node.js, well, then it's going to go with Node.js because that's for specifically that project. So we can create a new one, project steering. There we go. And then just start adding my rules into that. I just had, let's see.
So it basically serves a bunch of purposes, right? You can use it as guardrails. You can use it as sort of augmentation of the tool itself.
Yep, exactly.
Yeah.
So let me just add. Probably should have done these earlier, but it's fine. We control it through our prompt instead. But for instance, for my project, well, I wanted to use US West 2. And that could be specifically for that project. How I want the structure to be, backend, frontend directories. That it should use the template YAML, that I want to use Node.js. Default timeout should be 30 seconds. So then by adding these, I don't have to prompt everything. It's going to look at the project steering for it as well. So I can just save this. And now it's always going to have that as context with everything that I prompted to do. So I think that's a very useful thing to have when working with this, and especially then if you want to control the output of what you're actually building. All right, so let's get back to what we're actually building. So now we've created the API, the 2 Lambda functions. We're just doing text files for now, and then we're storing those in an S3 bucket, and we're able to return with a pre-signed URL to be able to fetch the images. So far, so good. I guess the next step then is to add Bedrock into the mix.
The actual image generation part, yeah?
Yes, so that one is a bit longer prompt. Telling it to replace the placeholder generation to use Titan image generator 2 on Bedrock. I got the model ID. We could leave that blank, then it will probably have to start searching to find it. So it'll save us probably a couple of minutes. But it would then start looking up through the APIs, basically, what model to actually use. Use the correct request format, generate a PNG from prompt, store it in S3 under images, return the object key. I'm telling it to add an environment variable so we can bypass Bedrock when we're doing testing, for instance, so we don't have to call it every time. IAM should be least privilege for Bedrock and S3. We want a bit longer Lambda timeout for image generation. So in this case, this is going to go against what I have in my project steering, but I had 30 seconds. And in that case, well, it's going to go with what I say in the prompt instead.
And I think one quick call out or a pro tip here is don't be shy with your prompts. Like, if you wanted to do a certain thing, I personally have this instinct of trying to get the prompt out and just get going. But take your time, think through it. The more specific and clear you are, the better it will do for you. You're just saving yourself some time for the next step.
Yep. All right, so now it's just going to, in a similar way, it's going to update our template to be able to add the infrastructure needed. And in this case, since it's Lambda who's calling Bedrock, it's basically about adding the correct permissions to be able to call Bedrock. But then it needs to update the package files to be able to use Bedrock runtime as well. And that was pretty quick. Yeah, here we go. This is the Lambda function. So it's added what's needed to generate an image. And now it's running SAM build again. And then it's going to do SAM deploy, hopefully, at the end as well. Here we go. Trust. There. And as soon as that's done, well, I guess we can test if it's actually able to generate images for us as well. And now I guess it's the same thing. Oops. Let's see. Is it already done? That was quick in that case. I'm not sure if I need, is it waiting for a prompt or not? Maybe. I always just agree to everything, so yes. No clue what that is. Oh yeah, here it's updating, so it was probably just me not wanting to wait long enough. Okay, so now it's updating again.
Testing time.
Yeah, let's see if this should be fairly quick. It's about updating the Lambda functions and just adding policies. Update, cleanup. There we go. All right, so now that's done. Let's see if it's thinking. Yep, updated the change log. And since this was big enough change according to my steering, it's then going to do a git commit as well. That was a very good commit message.
While that is loading, does anyone have any suggestions for what we want to generate?
So my was a watercolor hummingbird, but
There we go. That's good.
Is that
good for a Monday morning.
We should have, no, it needs to be Riemann themed some way, right?
Yeah.
Las Vegas in winter. Let's see if... OK, so telling it then to first generate and then test it out. Let's see. So it's run in curl. And since that's now calling Bedrock, it takes a few seconds. And we can see that it generated an image. And now it's going to try the other one. And yes, we're getting a pre-signed URL. If someone is quick enough, you can type it in and test it. There we go. It worked. Should we try? Do we dare to test it?
Moment of truth.
Do you really? Yeah. Placeholder. What's that? Oh, well, that's interesting. Placeholder for image generation. Images. Oh, it's still the text file. I don't think it updated the... So it's able to generate, but it didn't update the return API. Sorry? Oh, you're right. Yeah. Oh, yeah. It's listing 25 of them. You're right. That's good. Oh.
Wow.
That's exactly what Vegas looks like to me. So, yeah. I guess this is
there
winter.
You go. And how many lines of code exactly did you write?
0. Yes. OK, so it worked. Oh, yeah, good call out. So, yes, it's listing the text file as well.
All right, so we have the backend already now, and it works.
Cool. So can you remove the text file from the S3 bucket? Goes against exactly what you said.
Yeah.
Very specific with your prompts. I'm not saying which text file or which S3 bucket. Let's see if it gets it. Hopefully it should. Yeah, that was too easy. So now it's using the S3 API through the AWS tool. So now the API will hopefully not return that text file as well. OK, cool. So now we basically have our backend generated exactly how we want it to do. So I guess it's time to look at the front-end part.
Yeah, that's the fun part.
So like I said, I pre-created just a blank front end, Vite, React, and it just looks like this for now. So I'm running that here, npm run dev for it. So that's all we've done so far, just to save a bit of time. So let's try to add that prompt. I have a blank React Vite app in frontend, updated with a single page. Text input for the prompt, a button to call post generate, and a gallery that calls get images and renders pre-signed URLs as images. Add an environment file with Vite API URL, set to the endpoint, and now I'm tricking it again. Let's do like that. For now, skip authentication, commit the code. So now we're switching from making use of the serverless MCP servers. Now it doesn't really need to use those. So here we can see that it's using tools to understand the front-end directory. And it wants to make changes. Looks great. It's doing some CSS stuff as well. Let's see what this is going to look like. All right. Stage front-end changes. So it's adding that to Git. Did a commit message. OK, that was pretty quick. Oh, here we go. So this is our front-end application now.
Nice.
So one single prompt, it's able to just generate something I didn't tell it exactly how to use the APIs. It was able to do that. Let's see if it's able to actually generate something as well then. So now it's your turn to be creative. This is always the hardest part about
keeping the reinvent theme going. Let's say reinvent Expo Hall. I want to see what it looks like this morning. Just kidding.
Reinvent Expo Hall.
It's not an easy one. I purposely gave a more ambiguous one.
Right, so it's generating. So hopefully it's calling the API for us.
Oh, wow.
That's more like reinforce, I think. But yeah, it worked. Yeah. Okay, so it has a front end that's able to then call the API, generate an image with our backend, return a response, and actually update it, the front end for us as well, and display the image straight away.
Nice.
I think that's pretty cool. So now, obviously, most of us would not be happy with this front end. We would then iterate on it and add additional functionality. We would perhaps improve the appearance of it. And let's say that maybe I have my own design team that's actually created a nice design for this website. Well, I can just prompt it, tell it to look at this image or even this Figma template, that this is what I want my website to look like. And it would then work based on that as well. So you can do a lot more. The more specific you are, even using images, you can tell it exactly what you want the output to look like. And I think that's really the power of these tools, to be able to use proper context to make things happen. All right, so now we've made that happen. So I wanted to show something that I'll try to explain how I see this relevant. Many times, we don't start from scratch with something. Maybe we have something that's already deployed in AWS. We have some Lambda functions running somewhere, some project that we're already using. But then we want to make use of these tools to improve, to update, and so on. And there is a fairly new functionality in the console that I think is super helpful for this.
Yeah. So while you get it all set up, so like Gunnar mentioned, right? There are challenges. So when you start in the console, and let's say you want to transition over to your local IDE, you almost instantaneously get hit with these friction of having to copy code manually, configure credentials or set up dependencies. Other tools like linters, formatters, all of those things you actually have to set up. So what we went ahead and did earlier this year was sort of take away all the pain and make it a one-click experience. So if you're in the Lambda console, for example, and you just say open in VS Code, and it will open your VS Code instance, it will download, set everything up for you, so you are, there you go. You will just be able to get started in the console. If you authenticate it, it's literally just one click.
So just created a new one.
There we go, yeah.
Yeah, so created a new Lambda function. Just a Lambda function, but it could obviously have an API in front of it. It could have a bunch of stuff. It could be anything. But what we can do then is make use of this. So I tell it to open it in Visual Studio Code. And sure it's opening. Here we go. Move the window, ended up on the wrong side. Here we go. So it opened VS Code for me, asking me, do I allow the AWS toolkit, which is the requirement that you need to have that extension installed, to open. And then once we open it, sure, there we go. Yes, I trust. Here we go. So now, through that one-click thing in the console, we're able to open up that specific function. And like we said, it could be something that someone else has deployed, something that was created a long time ago. And now, from this point on, so many pop-ups in VS Code. From this point on, well, I can start doing the same things. I can now use Kiro to iterate on this, I can work on it, I can deploy it again. But with this, what happens when I store or make a change?
Yeah, that's literally my favorite part, right? So you make changes in your IDE, it automatically gets synced back to the cloud, so you do not have to keep hitting. It prompts you, obviously, it prompts you that you want to deploy, and you hit deploy, it automatically deploys to cloud. You don't have to make any of those changes. And one of the other things here is you could, and we talked about SAM a lot throughout the session so far, so from here you could also export your project as a SAM template. So if you want to start building using SAM CLI or something, you can from the IDE, you could just go export to SAM and start doing that locally as well. So as you saw, the experience has been much simplified to a great deal, to the point where you don't have to do anything. We've just taken care of all the scaffolding, all the setup for you.
Cool. All right, so that's a good way if you want to start using these types of tools together with something that's already deployed, perhaps. So back to our app then. What we've done so far is it's a working app, front end, back end, and it has the functionality that we want. But to take this into something that's perhaps production ready, there's usually a lot of other things we need to think about. And one key thing when we're building, and I think for serverless, it's super important to understand how your application works, and that's where observability comes in. There are a lot of great things with the way that serverless works, that you have separate functions, you have all the pieces are basically broken apart, makes it easier to understand what's actually happening as soon as you start adding logging, tracing, metrics, and so on. So that's what we're going to do now as the next step. And there is something called AWS, or what is the official name? Power Tools
for AWS Lambda.
Yeah. Power Tools for AWS Lambda allows us to do these things fairly easily. So it's basically libraries that you can add to your Lambda functions to start adding logging, tracing, and metrics to your application. So instrument your functions to understand what's happening. So I'm going to tell it to basically add that. Add Lambda Power Tools to both functions, include logger, tracer, metrics. I want to have a custom metric, images generated. I want to have correlation IDs so we can do request tracking. I want structured logging, and then rebuild and deploy. So I'm telling it that I want to have full observability, basically.
Yeah. And Power Tools is a set of libraries that sort of augments what we provide in Lambda out of the box. So you get structured logging in Lambda, JSON structured logging. We launched a couple of years ago. You could have previously done it as well using libraries, but we just made it native. You get all log level controls. What Power Tools does, it helps you extend that functionality to other things, and it builds traces from that and so on. And it's a nifty little tool, so we definitely recommend checking it out.
Yep. So as soon as this is deployed now, we're once again going to test that. And something that I use the Kiro CLI for a lot, it is to understand what's actually happening with my applications. Telling it to fetch logs for me, or telling it to look at traces and so on. Because it is then able to call CloudWatch to be able to get this type of data for me, but I don't have to do it, basically. So I can ask it very specific things, and it can go through a bunch of logs to find specifically what I'm after. So now it's using the serverless MCP again to run the SAM build, and then we'll do another deploy. So what we're doing now is we've been running SAM deploy quite a few times, and mostly because we've done infrastructure changes pretty much all the time so far. But we don't really have to do SAM deploy every time when we're just making code changes. We could use SAM sync.
Yeah, that is one of my favorite SAM capabilities, where you just do SAM sync and it automatically detects and deploys changes for you. It's obviously there's guided. You can have different options. I guess you're gonna use SAM sync watch or something, or just using plain SAM sync.
Well, I'm not doing it at all right now. So this is just.
Yeah, and it becomes handy if you're using, there's another capability called remote. If you're remotely debugging, for example, debugging a function deployed in the cloud from your IDE, And if you do SAM-sync, then you don't have to get out of that flow. You could continue making changes, and SAM-sync will keep deploying it for you. So you get the experience as if everything is running on your local device, when in reality you're debugging a function that's sitting in production.
All right, let's see. I'm in that state again, but I'm not sure if it's waiting for me or not. I'm always going to be unsure. Here we go. Updated in progress. All right, almost done. So we can test that as well. So these changes now, it's adding those libraries for us, so we're able to fetch all that data, and we're then able to have better observability into our application. Let's see if it's almost done. Yeah, update complete. Let's see, soon tight. Here we go. And then we can test it. I have my prompt ready. Yep. And then we obviously need to generate something. So we have some metrics.
Oh, you're looking at me for a prompt? Okay.
It's Monday morning, so.
Yeah. Monday morning.
Well, let's do that then. Monday morning. Let's see. All right, so now we're generating new, and this is to now generate some logs for us, so we have something to test as well. Hopefully that's done. The application now has production-grade observability with minimal code changes. And that's pretty cool with Power Tools, because you're instrumenting the code, so you don't have to write a lot of code yourself to actually create this observability. You're wrapping, basically, your function to be able to get it. Monday morning. Yep. I don't know that time. 10 past 8 and 7 at the same time. Okay.
Not too far off from what time you are at.
No. Fetch the most recent CloudWatch logs for the generate function in stack and show me structured log entries with correlation IDs. Like I said, this is something that I use it a lot for, to be able to understand, not only when developing, but also when, for instance, when trying to solve issues and so on. Let me fetch the logs differently. All right, so we found the log group. Here we go. I guess this is it. Structured log entry. Monday morning. Oh yeah, so here we go. That's our. So now we was able to then fetch that. We have a trace ID following the entire request all throughout. Cold start detected, since the Lambda function, well, first off, we haven't used it in a while, but it was also a code change.
Yeah.
That makes sense. Image generation took 12 seconds, and we have our custom metric successfully emitted. So it works. We're able to then fetch these logs, and we now have instrumented our Lambda functions. So what we could do now is obviously use CloudWatch, and we would have traces available. We can use CloudWatch and so on. There is a new feature in CloudWatch that I think is super useful for serverless.
Yeah, it's application signals. It is essentially AWS's APM tool, and it collects signals across logs, metrics, traces for your application, and it correlates them, and it gives you key metrics. Also, think of golden signals, latency, throughput, and so on. All of this out of the box by default. It's a one-click enable if you're setting it up for your Lambda function. And the part that I emphasize on a lot is that it uses OpenTelemetry to do all the instrumentation, so it can easily fit into your OpenTelemetry tooling that you already have. And you can extend it as well. Do we have time to show it, or? Yeah,
I'm adding it now. So I sent a prompt telling it to enable application signals. So I'm doing it through infrastructure as code, through my SAM template. It can be enabled in the console as well.
It's a one-click. So you enable it, and we take care of all the setting up.
And I told it to add it in the global section, so it should be for all Lambda functions. But it then told me, no, it can't be in the global section. So I told it the wrong thing. So it's adding it to each Lambda function. So it's pretty cool. Instead of actually deploying it and not working, it fixed the problem for me straight away. So here we go. And now it needs to run SAM build and then SAM deploy again because it's an infrastructure change. And then as soon as that's done, we are then going to have CloudWatch. Let's see if we get there. Application signals. So this is application signals. So it's basically an APM for our application. And it helps us then understand the application much better. This is a super cool new feature in CloudWatch. And I think it probably works best for serverless.
Yes, absolutely. It makes debugging and figuring out your serverless application much easier. With that, do we want to transition back to wrapping up?
Yeah, I think we should. So basically, we've been able to build an application that I think does exactly what we wanted to. It is able to generate images. We're able to return images. But functionality isn't the most important thing. I think the important thing is basically the way we did it.
Yeah.
I still haven't written a single line of code, and we were able to generate this, but still under control. So we controlled it. It wasn't just vibe coding, telling a tool to generate the application from scratch for us and then not knowing what was going to happen. We broke it down into small pieces and made sure that we were in control all throughout.
Yeah, I think the serverless MCP server was super helpful as well. It turned Kiro essentially into a serverless expert, with all the SAM tools, deployment guidelines, access to serverless land that I talked about earlier, and so on. And again, as you saw, that observability was not an afterthought. Like, we added it towards the end, but that's just the progression. We embedded it with power tools and throughout the process, not just observability, the guardrail security, least privilege, permissions, not giving S3 bucket public access. Those are things that we were able to do all again without having to, fiddle around with IAM policies and such. Yeah, and lastly, it also gives you sort of this easy transition between local and production, like basically a complete developer experience. All right.
So if you scan the QR code, it will get you to a list of resources, basically so you can easily download Kiro CLI, but also how you can find these MCP servers. We're linking the serverless MCP servers, but all the other AWS MCP servers are there in the same page. Serverless land, great resource for everything serverless. Lots of patterns, walkthroughs, articles, blog posts, workshops, everything basically. A lot of this is built around well-architected serverless lens. So the way that these MCP servers, for instance, work, it is built on well-architected principles.
Yes.
And then finally, a link to the Kiro CLI docs as well, where you can find more information about how to use Kiro CLI. And with that, we want to thank you all very much for joining us today. Well, thank you.
Thank you.